Good afternoon, everyone, and welcome to Permian Tech Talk. Thanks for joining us today. We are thrilled to have you here as we continue this journey of knowledge sharing and industry collaboration. As the moderator of this session and PioPetro's Business Development Manager of North America, I'd like to begin by introducing myself. My name is Jomana Abdurrazik. I hold a Master of Science in Petroleum Engineering from the University of Houston, and I'm currently working as an engineering project manager at Sherwood Logan Associates. It's my pleasure to be moderating this session today. Now I'm honored to introduce our speaker, Pierre Jean Daniel. Pierre is a senior account manager at SLB and will be discussing an introductory session about Techlog AI. For those of you who may not know, SLB, formerly Schlumberger, is the world's leading technology company for the oil and gas services industry with a global presence in over 100 countries. SLB is also known for its innovations in digital solutions, reservoir characterization, drilling, production, and processing. Their mission is to drive energy innovation for a balanced planet, combining advanced technology with a strong commitment to safety and sustainability. Throughout this session, we encourage you to submit your questions in the Q&A box, and we will address as many as possible. If you haven't already, we invite you to subscribe to our YouTube channel and follow us on the LinkedIn page PioPetro for updates on all our upcoming courses and forums. With that, please join me in giving your full attention to today's very special guest, Pierre Jean Daniel. Welcome, Pierre. Thank you for joining us today for a Permian Tech Talk. We are excited to have you here with us.
Thank you, Jomana. So yes, my name is Pierre Daniel. I've been in the US for on and off since 1998. And today I will be discussing about Techlog AI. So basically what kind of AI capabilities you now have in Techlog, which is our petrophysics or the domain, wellbore software in SLB. Just a little bit about myself. So I don't have my parkour so far has been a little bit sinuous. I started in 96 with a master in theoretical physics, so I'm a bit far away from my initial work. And then for the next 10 years, 12 years, actually, I work as a oil and gas tool development. I was working for SLB to start with. Then I moved to Weatherford. I also went to the Atomic Energy Commission. So I was touching with ultrasonic, fiber optics, also wind turbines, so different type of tools, every time related to physics. In 2008 to 2011, I decided to move to petrophysics with SLB. Then afterwards, I went to the dark side. I was working for 4 years as a BDM for Techlog, still with SLB in Asia and USA. And then the next 4 years, I had my own cloud company. Then I was a sales manager in MWD with Oliden during the COVID years. And I've been an account manager with SLB in digital for the last 3 years. So first, let's talk a bit about AI because it's a landscape, right? I mean, people talk about AI, they differently use the word AI, machine learning, deep learning, generative AI. And very often we don't know what it is. We don't know the differences. So the first thing is machine learning is a part of artificial intelligence. Deep learning as well, and generative AI is also part of artificial intelligence. So in machine learning is when the algorithm allowed to learn from data without being specifically programmed. So when I talk about explicit program, I'm talking about in the past you probably did that if gamma ray more than 25, if rho b is less than 20%, then you do this. Well, in this case with machine learning, you don't do that. It works with regression tree, decision tree, logistic regression. So it's not an explicit programming. You let the system work with a whole set of this, with a whole sequence of decision tree. The next one is a deep learning. In this case, what we had is a multiple neural network. And again, deep learning is not new. We have been using deep learning, machine learning, and neural network for quite a while. And I'll come to that in the next slide. So in this case, you start to simulate what goes on in your brain. So you have convolution, you have different type of processes which is happening, which is, it's not a straight answer. And that's when you have this neural network. So you have multiple layers all working together. The next one is generative AI. In this case, that's kind of it's a revolution in itself over the last 20 years, because you have a subset of deep learning. You're able to represent in abstract way the meaning of the logs and the languages, because you want to generate something which is human-like content. For instance, you can predict, you get a sequence of words, and you do it every day, by the way, in your brain. Like somebody is talking and you know what they're going to talk about. So you're trying to guess what they are going to say. So in a way, your brain is doing a generative AI work, in the sense that you're already predicting the next words. So it's the same here. With generative AI, we allow the system, we allow the computer to understand the context. We train the system to understand the context of a sequence of words, and is able to give you an intelligent answer, which is based on this original inputs. So this is, again, this is not new, right? So TechLog, for instance, the first neural network in TechLog was in 2004. This is a training which was delivered in 2009, which is called artificial neural network. So what is new here? What is, we could do regression, we could do classification, right? But what really changed is what we're asking the machine to do. We ask the machine to understand the text, not just to do a simple optical character recognition. Okay, I have a table, read the table, give me the numbers, put it in an Excel spreadsheet. But there's no context, there's no information, there is no understanding of the content. What we have been doing with these new AI capabilities, Gen AI capabilities, is to be able to understand. You import a report, but then you tell the machine, explain to me what is in this report. I want to see some gamma ray. I want to see some density. So you have to, you are training the machine almost like a young child, that you're training him to understand what he sees around him. Like if he hit himself with his hand, he's going to hurt. Well, next time that he hit himself, he will know that he's going to get hurt. It's the same thing with the machine. You give them so much data, so much information, that you're training the machine to give you a proper answer. And as the same as a child, you have to train the machine. I mean, if you give them wrong input, well, you don't get the right answer. It's the same thing with the Gen AI. But as we go along, there is so much development being done, so much data which is being processed now, that the machine is getting, I don't like to say the word smarter, but it is. It is kind of smarter, because it's started to really emulate what the human would tell you. And sometimes it's better than the human. So if we apply this to petrophysics, at the end of the day, what are we looking for? And I'm going to talk about the first step we did in TechLog and where we are going to. So what we want at the end of the day, we want to take away all the boring part of the job. For instance, I had to copy Excel spreadsheet. I had to read through 100 pages of reports. That's probably not the best usage of my time. When I was a petrophysicist, for instance, I would spend 80% of my time doing this and 20% of the interpretation. Can we just reverse it? Can we make sure that the high power, the things that are not mundane or repetitive, that the machine can do, then you want the user to do it. So again, we're not changing your workflow. We're trying to take away the tasks that you don't want to do. For instance, you have a master, you have a PhD. Well, do you really want to spend your time copying table? I don't. So in this case, we can make the job more enjoyable, and of course, for a company, it's also more efficient. So let's talk a little bit about the AI here. This is a journey. You see the data discovery, you see the report review, you see the data preparation, control model, scenario analysis, decision. You're doing this on a daily basis, I'm sure. Data discovery, well, if you look at Total Energy, for instance, they were saying that they were using only 10% of the content of the report. They were able to use it. Not that people are silly not to use this report or to understand it. They don't have the time. And then the next step is report review. So data discovery, report review, and data preparation, Petro model, that's all about quality of the data that you're taking. So for instance, you don't have the time to read the report. Well, in that report, there was a very important information that you missed. Well, that could have changed your interpretation. That's what we're trying to solve. To do this, we use LLM. So what is an LLM? And I will give you the definition of large language model because people use these words, but most of the time they don't know what it means. It's an artificial intelligence system. It is trained on the vast amount of text data to understand, summarize, translate, and generate human-like text and content. So in short, if you want, this is the whole definition, but in short, it analyzes the data, it recognizes patterns and relationships to predict a relevant output. Now, of course, if you give them bad training information, you're going to get bad results. And that's where the training is very important. Now, the another word that you're going to hear, and it is in the slide as well, is what we call log foundation model. So what is a log foundation model? It looks very kind of magic, right? Well, it's the same as a large language model, except that you're training your system on logs. You give them lots of logs, instead of giving them data, text, and so on, like everything which is in the web these days, you give them logs to the system to help understand the relationship. I want to know the relationship in that specific zone between the gamma ray and the density, or gamma ray and resistivity, because this is whole system. There is a relationship. Nature is not independent. Density is not independent from your computational slowness in that environment in particular. So that's where you are teaching the system to fully understand how they work together. So two steps here that I would like you to think about is the first block is when we have the data discovery and the report review. We talked about the fact that people don't use all the information they have. It's locked in a way, not because you cannot understand it. It's locked because you don't have the time, or sometimes we have a miss of attention when we read a document and we're missing one sentence which was critical. Like for instance, it's well cemented. Well, you missed it. Now you know that the slowness should have been slower. You don't know it. And again, in this first point, we want to accelerate your report review so that you can move to the next step, which is the most fun. And the second part here, which we call data preparation and Petro model, is when you want to get better predictive model, you leverage on the log foundation model, on the model which has learned from many places, which has already all these parameters in place, and you can move on. Now you know that you have already a solid foundation. You can adjust it to your environment, but you already have a solid foundation to start with. Two challenges. When we did this plugin, this AI plugin in Tekla, two things that we had to think about. First, we are not just in the US, we are worldwide. So there are some data security, there is some compliance, there are some countries where data cannot get out. There is some companies where they don't want to be on the cloud. They could, or maybe they don't want. And then they want to be able to follow these strict rules. But they also would like to have access to this technology. So this is one of our challenges. The second one is the cost. When you talk LLM, at least it was the case for me in the past, I think about money. I think that it's going to cost a lot of money to do it. And then maybe it's not going to be scalable. Maybe it will not be sustainable. Who is going to take care of it? I don't have the IT guy in my company. So who is going to take care of it? So that's the two challenges that you have to keep in mind, that we kept in mind when we're developing it. So what we did on this journey that I showed before, we did the first 4 blocks. The first one is import and extraction. You want to automate, you want to take the human out as much as possible, except for the QC at the end, from this really tenuous task, and you want the system to do it for you. So you have this agent, this AI agent, which is searching for this information. It's extracting this data that you need from historical report. And you will see in my demo that some of these reports are really coming from the 1950s, right? It's just, it could be handwritten, it could be in such a state that even you as a human is looking at it, it's like, what am I reading? And the next step is when you have extracted this information, although we have some QC, automatic QC out of this import, well, you have to use it. So the next step is to use it to predict missing logs. You can help it to get better interpretation, or just missing logs, or just missing blocks of logs that you need. For instance, I was in petrophysics, seismic petrophysics. If I didn't have the density in some section, I couldn't work. But I just could not create it. I would have created with a pencil, right? But it wasn't good enough. I had to have something solid, otherwise the next guy doing the 3D seismic would be completely wrong. So that's something that kind of my pet peeve in a way. The QC is always misconsidered, and it is the foundation of anything you do. Like you could spend 3 weeks, sometimes you spend months on a 3D model, and the initial density or the initial compressional value is the critical. If this is wrong, everything is just going to the drain. When we did that, we kept the flexibility I talked about on-prem and cloud. We wanted this module to be able to work in both situations. You have to ensure the flexibility, the security, and the compliance, the local compliance. Just for the technical people in the group here today, just a bit on the architecture, the way it works. So first you have the TechLog plugin. So on the left here, you have the PTE user. And this PTE user is going to upload a file. Actually, when I say a file, it could upload 20 files, or it could upload 100 files if he wants to. And then the TechLog, the platform itself, the plugin, it's a regular plugin. In this case, it would be an on-prem plugin. It works with a license. The license can be on your machine, can be on your server. So you can share this plugin between multiple users. Well, it's running on extractors. The extractor's job is to start processing the image, identify the page, ask questions to the LLM, which is on the right side. And I'm going to go to the LLM on the right side afterwards. Then you get the response. Well, the extractor is going to check, to do a run, to make sure that the information that the LLM, the LLM, again, it's a machine. Same as humans, they can make mistakes. So we have to do a double check if the log is within range, or if the order of the formation is correct. It can happen that it's wrong. In this case, you kind of have to threaten the LLM that they have to do a better job. Then you have, in the same TechLog application, you also have the connection details. What do you do with the connection details? This is where you manage the password or the login to be able to connect to the LLM. And finally, you have the certification test object. This is kind of an obscure module there, but that module is used because we leave the choice. We don't force the company to use our LLM if they don't want to. They can use the LLM they want. In this case, we run some tests to make sure that the LLM is at least good enough. And then depending on the quality of this LLM, we're going to activate or deactivate some functionality, because otherwise you could trust your LLM, although the quality is not there. We would tell you which one to use by default. If you want to be on-prem, if you want to have an open source, you can have one from Dataiku, for instance. Dataiku, again, works on cloud. Dataiku can provide you the LLM access, and it can be on-prem, on the cloud. Always, in everything I'm talking about today, it's always on-prem or cloud. It's up to you. It's up to your company strategy. And finally, on the right side there, you have the admin user, where the guy will control, the administrator will control who has access to it, who can run this LLM. So let's go a little bit about a demo, because this is what I talked about, the discovery and report review. You have this file import and extraction with AI. So let's look at it, see what it is. So what you see here is a TechLog module. You have different markers. You have core porosity, formation pressure, markers, mud logs. And this is constantly evolving. Like at the moment in preview, it's already working, but it's not commercial yet. We have training events. We have lithology for mud logs. We have production logs as well, which don't contribute the most. We can look for this in kind of information in your report. So what you tell the system, do it. And you click on what you want. I wouldn't want, you can do all of it at once if you want, or if you're looking just for the core porosity, permeability, grain density, you select the first one, you say, okay, this is what I want. And then you run it. When you run it, and I'll show you, I'm going to show you one of these report. So this is the report we get. If you can see the quality of it, it's basically awful, right? And still, the system will be able to understand this is formation markers. This is the top. And it's able to get it as a marker object in TechLog directly. The next one would be, I mean, we have tested it on many type of file. This one is one of my preferred one because it's so bad. You can see here, even the depth is not even written because the person didn't want to spend time doing it. It's a core analysis. He didn't put the 2700 for any of them. And still, because we trained the LLM or the VLM in this case to understand the context, it's able to understand that, okay, this is 7273, but really it is 2772 to 2773. And it's able to understand this is porosity. But even with my eyes, if I didn't know it was written porosity, I don't know what it is. It's still able to make it work. And even with the eyes, if you go with somebody which is outside of the oil and gas, no clue what it is. And grain density. So what you do there is you process it. So you select your file. Another one would be, for instance, a report by SRB here, which has lots of tables, and you want it to be automatically put into TechLog. Again, as you can see, it's going to be a huge amount of time saved. And then you say you run it. So I'm just going to speed it up. So you run, see, depending on your GPU, so typically you need a video card, like a 48 gigabyte GPU video card. It's like an A6000. It's about $5,000 to put that in your machine. That can be put on a server, and that server can be shared with other people in your company. So that makes you having the ability of the general AI capabilities now at a cost which is quite affordable. And it takes a minute, sometimes a bit less, depending on your GPU, to process the file. And this is a result. This is the original file on the right. This is a new file, or the TechLog format on the left. And now this one is going to be automatically ingested as an object in TechLog. So if you are like me and you like a machine to do the work whenever it's straightforward, pretty sure you would like it. We have some quality control around it. Like for instance, one of them was giving us a porosity of 130, we would take it off. We know there's a problem. It's not right. It should be between 0 and 50, maximum 55, but that's pushing it. And then you can do multiple in parallel, of course, like I said before. Now, if I continue, you just have to say, okay, where do you want to put it? And it comes as a data set in the right well, and you're ready to go for the next step. So once you have imported this type of document, I mean, some of the documents I've seen were just handwritten, no lines, whatever, and still the system is able to see it. So in a way, it's almost like magic, because I would not believe that it was able to do it. But it did, because there is a combination of visual language model as well as OCR. The system are kind of cross-checking each other to make sure that data is correct. The next one here is a log prediction and the tuning. So what we did here, we talked a bit earlier about log formation model, which is the same as LLM. So log formation model, except it's for logs. So SLB has taken public data everywhere in the world. It was USA, Brazil, Australia, Norway, and some other location. So we trained the system on 18,000 wells to understand the relationship between the different inputs. Now, this has been trained, just a grain of salt here. This system has been learned on public data. Again, like we go back to what we said earlier, is the system is as good as you can train it. So that's why we have added the functionality to it, which you call tuning. So, like for instance, we don't have the geology, we don't have public data from Azerbaijan, for instance. So the person in Azerbaijan can tune it to their own wells. So not only they would use the log formation model, but they can fine-tune it. There's 60 layers total. The last 3 layers of the neural network can be fine-tuned for your environment. And then this model, that becomes your new model. You can save this new model in your company folders. And then you can reuse this model later on, depending where you are in the world. That's just to be able to reduce the uncertainty. So if I go to a demo of it, or the people which are working with K-Mode, it would be quite familiar. What's going on here? You have your inputs, and this is your target. So in this case, the target was an NMR. This is different inputs. In the version in that demo, which was, you had to have the input to be able to make it work. In the version which is coming this month, you don't have to have all the inputs. Once you're missing the computational slowness, it's okay. You can still use it. You can put the input, you can just use the input that you have to get this output, because what is missing is going to be taken over by the log formation model. Another case as well, I'm just thinking of that just now. Let's say, for instance, before with K-Mode, with the previous neural network, you were using your wells to train your system. And seriously, I love K-Mode, it was great. But what happens if all your wells have the same washout in the same zone? Can't use it. You won't be able to create the model in that zones. Well, that's where the log formation model comes in to help you. Let me just continue the process. So what you do here, you select the model where you want to learn, but we call it tuning. This is a validation. So the validation is more like a blind test, if you want. So the system is going to learn on the wells that you use to fine tune it. And the validation is what you use to check if it's correct. Like as you see, as we are going into more and more iteration, the system at some point has reached a local minimum, which is good. And you can see that even after 3, it looks like it was okay, right? But in reality, it was not. Because when you apply it and you do this blind test, it was not good enough. But as you go along, then it's becoming more and more solid. In this new version, there is a limit. Like for instance, it reached a limit here on the iteration. So let me just go back to the iteration. So it reached a limit on iteration. If you were continuing too much, let's say you would go to 30 or 40 April, you would think that it's going to go down. It does not. Because what you do at that point, you overtrain the system to a specific, very specific zone in the world. And that it would not be able to apply to another zone, to another well. Because you trained it so much for this that it cannot do anything else. So now in that version, we make sure that you cannot go and overtrain. So going forward, so what you had here is you were looking at the wells that you wanted to use. In that version, the curve that were not present could not be used. In the new module, so that's why they were taking it out. In the new version, you will be able to use all of them. You'll be able to use all these wells. It's just that be aware that the one where you're missing inputs, the uncertainty will be a bit larger, for the prediction. And then there you have, see that the curve, and you predicted your NMR porosity. So what we did is we went through the finding port and extraction. Now going forward with SLB is we want to go to the next step, because that was a foundation for the AI. You need this finding port, you need this extraction, you need to work. And then you also need the log prediction and the tuning. Now the next step for us, for the future, and what we want to present to our users, is the ability to integrate this information in their workflows. Like for instance, you have a petrophysics workflow, you have, but you need to have this extra information that exists in the reports to be able to fine tune what you're doing. And that is the end of my presentation. Would like to get your questions. So if we don't have any question, I can at least maybe there's some questions that always come back to me. The first thing is one of the questions which always come back to me is the data. Is my data going on the cloud? No. It's the data stay on the server where the model is. Like for instance, you decide where is your large language model. It can be on your own server, it could be on an external server, but that's where the data stay.
Thank you so much, Pierre. Great session with Pierre, Jean, Daniel. Very enlightening. It was a pleasure having you here with us on Permian Tech Talk. Now we'll start by asking some questions from our audience. Could you please share a specific case study where Techlog AI significantly changed or improved the reservoir understanding compared to the conventional methods?
So there are there is a paper coming up in Nature next month where I don't have the specifics of this paper, but there is this paper coming up in Nature where they will show the difference between these AI capabilities versus the previous, like for instance with K-mode. They are showing how much it improved it. Now it's like 96% accuracy compared to before. There is about a 50% improvement. And if you can get the name of the person, I'll be glad to share that paper with that person. I just don't have the specific of it.
That's awesome. That's actually a really good percentage too. Can you explain how Techlog AI integrates traditional petrophysical workflows with artificial intelligence and what sets it apart from the earlier versions of Techlog?
Okay. So with the petrophysics workflow at the moment, the way it integrates is I'm not sure to understand the question, but I will try to answer. So when you do a petrophysics workflow, you have these inputs. You need the triple combo, for instance, to be able to do an interpretation in ELAN, for instance. But very, very often the problem that you have is you're not sure that the data is good. Sometimes you're just missing the data completely. For instance, I'm thinking of geosteering. When in geosteering, you only have resistivity and gamma. Good luck to do interpretation. So in this case, what happened is you are able to get this extra information or these extra logs that without it, you can't do your workflow. So I think that's what the question that it was about. I'm not too sure I answered correctly, but that's where it is coming from, is the prediction, the extra information from the report that you need to do your workflow. That's how it integrates, because if you don't use this AI import, if you don't use this log prediction, how do you want to do your workflow? You don't have the information.
Yeah, that's great. Another question we have here is what type of data inputs, like is it logs or core data or images, does Techlog AI handle best? And how does AI improve the interpretation of these data sets?
Okay. So the first one, there's two modules to it. So well, in this Techlog AI at the moment has these two functionality. The file import use PDF or TIFF. That's for the data extraction. The log prediction use core and logs. So you need a core. So what happens is the file import and extraction, get it from the report, convert it into an object, which is basically a CSV object, right? It's just a point object. It could be a core, it could be a log, but the log at the end of the day is just a point object with a depth. And then you use that one for the prediction. So this is your inputs. So the image is not the input of the log prediction, but the image could be, it's looking at an image when you then look at the file import.
So from a company's economic standpoint, this is a question that I had. The more the data, the more you are spending to for that data acquisition, what is the least data that you could have to as an input data for you to be able to get that prediction?
Okay. Well, you can just start from gamma ray because we have the log formation model in the background. So the log formation model has already worked on 18,000 wells. So, and with multiple inputs. So all of this data have already been curated. The one we trained the system on, we have validated the input, we have validated the output. We know that this model work. I mean, that it worked with a certain precision. And of course, if you want to be even better, you can fine tune it. But in this case, you can start with a gamma ray, but it will work. It will work with the gamma ray. Now the accuracy might not be the best, but because all of this relationship between the different input, like computational slowness, density, and so on, has already been done, you're not shooting dark. You're shooting with, at least you know where you're shooting. Otherwise, if you go with a gamma ray alone, there's no way you can predict anything. I mean, gamma ray can be anything at all. It can be from 140, it can be 250, it can be anything, or it can be 80. In this case, it just reduces the risk that you have a misinterpretation of what's going on. And there's no way you can predict from gamma without the log formation model in the background.
That's good to know. There's always the economic standpoint where you're like, well, how can we mitigate this with the least cost?
Right. No, it helps. It's going to help because if you have this model which is already helping you engineer, it's driving you engineer on the road where they want to go. It's really meant to help people, not to go into the wrong direction because they missed something. It's really meant for that. In this case, I mean, I would never do a prediction on the gamma ray alone. Just if it's never. I would not. But now if I have a system which has been trained for it, which is, I know that it's more correct, there's just a chance that I'm right. Otherwise, I have no chance.
Makes a lot of sense. Thank you. Another question we have here is how does Techlog AI manage uncertainty of data, quality issues, especially when working with incomplete or noisy well-logged data?
Okay, so we looked at the range of the data. First, when we do the extraction, let's talk about the file extraction. It's looking at the data that it's extracting depending on the depth. So there is multiple validation. There is a depth validation. For instance, data is not going to jump from in 1 feet from 0.1 to 0.5 PU. It's not going to be 10 to 50 in 1 feet. So there is some validation about what it's reading. First is checking, is it in range? Does it make sense? Is it a range which is valid for that kind of measurement? Second thing, if you're looking at permeability and porosity, there is a relationship, a physical relationship between porosity and permeability. Is it, are we far away from this relationship? If it's too far away, there's something wrong with this data. When we train the system, we also train them on conventional and unconventional data. So the system can look, I mean, there's 166 million parameters that it's looking at. And if it's not matching, something is wrong. It's not just looking at one curve and be done with it, or one data point. No. It's looking at, not only it's looking at the, like for instance, if you look at the porosity, it's looking at the porosity column to see if it makes sense. But it's also looking at the porosity versus the other column. Does it make sense? Is it within what we are expecting? If it's not within what we're expecting, there's something wrong with it. Maybe the LLM got it wrong. And then we tell him, hey, you got it wrong. Do a better job. It's all about training the system. At the end of the day, the more you train it, the better is your log formation model for your own company. You can use the one from SLB to start with, and then you improve it depending on your order. But if you remember what we talked about initially, is the extractors, their job is to validate that it's not getting wrong done.
Makes sense. Thank you. Another question I see here is, how does Techlog AI integrate with other SLB platforms or even third-party softwares?
Right.
Can it be part of a larger digital ecosystem, if you will, for reservoir characterization?
Right. So this plugin that you have in Techlog is going to be put into Petrel at some point as well. It could work in Petrel. So the same functionality, the same type of import and agent, or the same type of work of prediction can be put into Petrel.
That's really good
So,
to know.
and then between Techlog and Petrel, of course, you have Studio in the middle, which is Studio is our data connectors between the two different softwares. So whatever is done into Techlog can be called into Petrel through Studio. But the plugin itself can also be put into Petrel.
That's great to know. And from your perspective, how is AI adoption in petrophysics being retrieved across operators in the Permian or globally? Are you seeing faster uptake compared to other digital tools?
Okay, this module is fairly new, right? It's only like 2 or 3 months. And when I presented it to different clients here in the US, I was actually very surprised by the interest of the people. I mean, when you show, for instance, I mean, in petrophysics, when you look at what the type that the document can ingest, the quality of the ingestions, the really old, just old, that really terrible document that it can read, I'm amazed personally by the quality of it. And I've seen that with my clients as well, is we want to test it. The reaction, I mean, I only started promoting it 2 weeks ago. And so far I have 5, 6 clients which are like, okay, can I test it? How can I test it? They want to try it out because they realize that there is so much to gain from taking away all this boring task. So it's coming together, but without AI, you can't do it. It's just, we have tried. I mean, before we had other tools to be able to have OCR tools, but there's no way you could do this kind of understanding of the document. It was not there. So AI has been there for a few years, but it's very new that it's in the oil and gas at this level. It's becoming mainstream, and I've seen even some of my clients are quite small company. They want to test it because they realize, oh wow, I don't need to have all this infrastructure around it. So far I was only staying with the big clients, the one which has a lot of means. And now we are, in a way, I don't know, can I say that, but we are democratizing it. We're bringing it to the smaller player because they realize that what they just need is a nice video card.
Sometimes these technological advancements aren't as welcomed as you think they would be, but that's really good to know.
Yeah, they stay with the one which have the big means, but okay, there is a lot of in the US alone, there is like 10,000 companies, and not all of them are big companies. And they would love to have their hand on these kind of tools. But now, like for the module plus 5K for a video card, you can use it. And it's not, I mean, you've seen my demo, it's not rocket science to use it. To use it, not to develop it, but to use it is not rocket science.
Right. So how do you see, looking forward, how do you see AI evolving in petrophysics over the next 5 to 10 years? And what role will Techlog AI play in that transformation?
Okay, that's a that's a fun question. So the way I see it is, I think you will still need the petrophysicist, at least maybe not so many, but you will still need. Second, so now we have the import, we have the log prediction and the tuning. The next step is to go to the scenario, to go to the decision. And there is a lot of information which has been extracted which could be put into interpretation module and use this module, just do this interpretation by itself. So for instance, today we can do that. I mean, we can use, we could automate it and have the log prediction directly into interpretation module. And then the interpretation will do the analysis. I mean, it will find the right parameters, it will optimize it. Okay, good. But you may be completely off. But now if you add, if the result of this interpretation is put in parallel to what the Gen AI understood from the document, you start to have, it's kind of scary, but you start to have an interpretation which is human-like. So suddenly, and you still need the human at the end of the day, because don't forget, it's just a system. But the result is getting more and more closer and closer to what the human would do, because now we start to understand what is in this document, what is in all of these reports, in parallel to what's going on in your final interpretation, which is a set of equations which have been put together to give you the result. I mean, Quantiline, for instance, in TechLog, is a set of equations which have been together that you're optimizing to make sure that you get the real answer. And you're optimizing the parameters yourself as a petrophysicist. Well, these parameters, to a certain extent, can be optimized based on what is in the reports. So as we're going more and more together in the next 5 years, we have seen already the changes in the last 2 years. It's we are taking away, I mean, to me, in terms of AI, the innovation will still be, at least just a personal view, but the AI cannot replace innovation of the human brain. But otherwise, when it's just a set of applying equations, you can use an AI.
That's good to know. So if you could highlight just one key limitation that still needs some improvement in AI-driven petrophysics, what would that be, and how is your team at SLB addressing this?
Okay, so one of the limitations, for instance, is the agent when it comes to look for markers. So you have to have the list of markers already existing. So in your TechLog object, you have, we saw some of these markers, right? This list of markers need to be you have to have this list of markers in your project. And then you tell the system, look for these markers. So at the moment, we're not able to say, find the markers out of the blank, right? We have to tell the system what it is. Simply because how would the system, I mean, humans are the people use all kind of names for their markers. How would the system know that it's a marker? It's one of the limitations. It's just because we are very good at inventing names. So core porosity, yeah, that's a known. There is a definition what is a core porosity. So the system can train on that. But how do you want the system to train on all the markers that people are using? I mean, it's infinite, right? I mean, I can call it today backend, or I can call it REST tree or whatever. I can call it whatever I want. So it would always be difficult for the agent to figure out that this is a marker, that it's not something else. So that's one of the limitations. You still have to tell him, this is the kind of markers that I'm looking for.
That's awesome. I have one last question from our audience here. They wanted to ask about your if there's an email or a way to contact you with any questions after the session.
Sure. So actually, my email is at the beginning. Let me just go back to the slides. So this is my email. It's pdaniel@slb.com. It's very short. If you would like to send me information or send me email or whatever, just don't hesitate. And I will make sure that I answer your questions.
Awesome. Thank you so much for providing your contact. Um, Again, very enlightening session by Pierre Daniel. It was a pleasure having you at Permian Tech Talk. We are absolutely happy by your presence here with us today. Great session. And thanks to SLB for being one of the companies on this Permian Tech Talk series. Again, the attendees of this session will get an attendance certificate. Pierre, thank you so much for joining us, and thank you everyone for tuning in with us today.